They saw these crazy kids out there working all day long on this weird technology. So the community really rallied behind us. As our whole system went down, we didn't know what to do, and we couldn't find a replacement part, and there was a race against the clock, and someone had an idea saying, like, a toaster has a specific type of resistor, and let's just go buy one at Target. And the lady was like, do you want a warranty on this toaster? And I said, no, ma'am, we're going to destroy it.
Hey folks, I'm Conor Gaughan, and welcome to Consensus in Conversation, a podcast where we're talking to the innovators, entrepreneurs, and thought leaders who are committed to building successful businesses that also help us build a better world. I'm really excited about this week's episode, because while it's cliche to hear about startups catching lightning in a bottle, my guest today is very literally doing just that. Or catching lightning in a reactor anyway. But that's only the beginning of the story. The real question is, what do you do with lightning once you've caught it? And that's the part that might surprise you. Because I'm guessing a lot of you might hear lightning and think this is a story about renewable energy. And it is in part, but renewable energy is really only the first step of the innovation process here. What we're actually talking about today is fertilizer. Now, those of you who have a background in agriculture or the commodity markets probably already know how important fertilizer is. But for the rest of us, the importance of fertilizer, I think, is something that we most likely sort of know intellectually, but which we really don't have occasion to think about all that often. But fertilizer is really, really important. It provides the soil with some basic nutrients that plants need in order to grow, most especially nitrogen. We're going to dive more into the specifics of the process in the actual conversation, but I wanted to lay down a baseline just so you understand why this topic really got my attention. Globally, the amount of naturally occurring nitrogen in the soil before fertilizer is only half of what's required by agriculture to produce enough food for the entire population. That is, 50% of our entire world food supply is totally dependent on fertilizer production. Or to make it even more concrete, flip a coin and that's your chance of being here without synthetic fertilizer. But while the current industrial process for producing synthetic fertilizers is critical to the existence of society, it also has a big problem. It is a major producer of greenhouse gas emissions. So, this is the potentially billion-dollar question. How do we find a solution that allows us to build a decarbonized, sustainable future without compromising one of the most vital links to our food supply chain? Well, my guest today may have just found that billion-dollar answer. And yes, it involves lightning. Nico Pinkowski is the co-founder and CEO of Nitricity, a potentially game-changing startup that uses renewable energy to synthesize fertilizer. He's dedicated himself to making a difference in one of the most challenging fields in science, earning degrees in mechanical engineering and his doctorate in energy systems from Stanford, where he also caught the entrepreneurial spirit and began building Nitricity as part of the Stanford Energy Ventures program. It's a pretty classic startup beginning, but as you'll hear, the journey has been anything but ordinary. And Nico and his co-founders have gone to some truly incredible lengths to prove the value of the technology to the world. I'm super inspired by his hustle, his drive to make an impact, and his vision to apply Silicon Valley engineering expertise to one of agriculture's most important challenges. There's a ton of interesting ground to cover, so let's jump right in. How's it going today? Thanks for joining us.
Good. Thanks for having me.
So let's start at the beginning. Tell us a little bit about where you're from, growing up, kind of thing.
I'm from Colorado and pretty proud of it, actually. My family's like 6th or 7th generation Coloradan. And I grew up in Douglas County, born in Denver, and then went to school up in Boulder.
I don't think we talked about this when we previously got to chat, but I'm originally from Colorado too.
Amazing. What part?
I was raised in Littleton, and then my folks moved to Golden when I was in high school.
I love Golden. There's a great pizza shop in Golden.
Woody's?
Yeah.
I miss it. I miss Colorado. I don't get back nearly enough anymore. And it feels like, the state's gone through such a transformation since it just feels like every time I get back, it's 10 times bigger than it was the year before or the 2 years before. It's amazing.
It's the best known secret now.
Yeah.
Colorado's amazing.
Yeah. How'd you end up at CU Boulder? Did you like it there?
I did. I was debating between Mines and Boulder. I always liked math and sciences, and so Mines is kind of a great school for that. But I just really liked the city of Boulder campus, and then downtown, Pearl Street, the hiking, the running. if you like the mountains, Boulder is just a phenomenal place. And it was a great place to go to school. So that lured me in.
And so you knew you liked science and math, and you studied mechanical engineering. Did you know that you wanted to be an engineer? Was that always kind of in the cards?
I didn't. I really liked math from an early age, and I thought it was just this great puzzle and it was very competitive. And I'm a very competitive person. And so I got to be competitive in sports and I got to be competitive in math. So, my family members said, "Hey, you're good at math. You should consider engineering." And I also like physical stuff. And so I decided to do mechanical engineering at the recommendation of one of my family members, and haven't looked back. Really love it. Specifically, I'm one of those weird people that likes thermodynamics. Most people, you go into your undergrad curriculum for engineering, and everyone is begrudging and having to take thermo. But for me, I just couldn't get enough. Thermo is oh my gosh, I could eat up every thermo class.
Just fired you up. No pun intended.
I don't know. I was just good at it. It made sense, and it involved energy, which I really liked. So thermo is really the study of energy, and it drives our world, and it's complicated. It can get really complicated, and for me, it just clicked. Yeah,
and you really did lean in. I mean, you get your degree in mechanical engineering, and then you go back to school or stay in school and pursue some advanced degrees. What was it about engineering and school that was yes, let's just keep going. Let's get the master's. Let's get the PhD. How did you know that was the path you wanted to stick in for a while?
That's a good question. I think it was summer of sophomore year in undergrad. I was traveling Eastern Europe, staying with my family. So I was in Pristina, Kosovo, and thinking about what I wanted to do with my future. And I wanted to set an ambitious goal that would push me to achieve the most in the short term. And getting a PhD is what I centered in on. And then I only wanted to get a PhD if I could go to Stanford, Berkeley, Caltech, or MIT. And so I wrote down this list of 5 things. Okay, I need good grades, I need some letters of recommendation, and I should study really hard for this GRE test. And getting into Stanford was one of the most impactful days of my life. It was a goal I was going after for many years. I think a lot of people at Stanford are accepted and get in just because they're just pure geniuses with a 250 IQ and just amazingly brilliant people there. For me, it was definitely the result of a dedicated multi-year campaign pursuing professors who knew someone who knew someone there to say nice things about me and things like that. So that was how I got there.
And did you have a sense of what, beyond knowing that you were passionate about thermo, what you wanted to study, what you wanted to do with an advanced degree at that point?
Change the world. I don't know.
Yeah, that's a fair answer.
I mean, I wanted to make the world a better place. I'm from Colorado. You're from Colorado. There's a big focus on the environment and sustainability there. If you spend a lot of times in the environment, you just fall in love with it. And I have a certain set of skills, good at math, good at thermo, and climate tech, had this strong calling for me.
And you get into Stanford on this set of skills that you're excited about, that you're passionate about, and you end up working within the Stanford Energy Ventures program, which is prestigious and very specific in discipline. So I'm curious, was that something where you knew you wanted to end up when you got to Stanford, or was that something that you got there and found a home within Stanford Energy Ventures?
So at Stanford, a couple of years in, I was starting to get that bug for entrepreneurship, because you're in Silicon Valley and you start to think about what's next for me after grad school. And let's build a multi-year campaign to get there.
You're big on the multi-year campaign.
I mean, some people have to. Yeah, some people just find their way into all these wonderful successes, and other people have to work at it for years. And so I was going to all the climate tech events. Stanford's great because you can listen to all these great guest speakers talk about climate technology and climate policy, et cetera. And then this class called Climate Ventures had some amazing professors with a great track record. And I went to an info session on that, and it just blew my mind. It just sounded like something I had to be part of, and I wanted to make a team and try to put together a climate venture.
I mean, you kind of hint at this, but Stanford, by virtue of location and history and provenance, just imbues entrepreneurial spirit, it seems like, to everyone that's there. I remember touring campus and feeling the energy when I did it 20 some years ago, even. I'm curious how that rubbed off on you. Do you remember kind of feeling that shift in perspective from, I like math and science, I like thermo, I like energy, to, starting a company, entrepreneurship? Like, can you look back and think about the transformation or the evolution as that kind of got into your system?
Starting a business and Silicon Valley are so connected. There's such a romance of going to Silicon Valley and like beginning an entrepreneurial venture. And there's so much history here as well of people that have done it and have like taken ideas to become real products and have consequently changed the world. And so for me, there was this like sense of adventure in that, and honestly, a sense of like romance.
Yeah.
Going to Silicon Valley, being involved in taking a transformational idea into something that's real. And then also that, there was a potential to do that with thermodynamics and energy sciences and something that's good for the environment. It was just incredible. And there's like very few places on earth that give so many resources to support people trying to do that, people trying to take big swings, that it felt surreal. And there was like a couple moments in there that felt particularly surreal. But like my first meeting on Sand Hill Road, we're going to that little like hyper expensive lunch restaurant on the top of Sand Hill Road, and like meeting with a venture capitalist talking about X, Y, and Z. And you can just like feel the history, or you can see like a successful investor in the corner of the restaurant, or even like touring like downtown Palo Alto.
Sure.
And seeing like bits of history all over the place. That's incredible. And I was very fortunate to have like these opportunities being in this space at a time where you could do that in climate tech with thermodynamics at its core.
Were there professors or peers or classmates that either inspired you, influenced you, or where, the conversations, the classes, like you look back again and think that was part of the spark that got the ball rolling?
It's a good question. For me, there was this program that started the week before the PhD program started. And it was led by a previous professor, but now the head of the John Doerr School of Sustainability, Professor Majumdar. And also it had guest lecturers come in, like previous Secretary Schultz or like Condoleezza Rice, come and give talks about energy. And then they also, you apply and you do these like competition games with other students at lunch. And I was like, okay, I'm smart and good at competition. And then it was your first experience at Stanford. And I just realized everyone was way smarter than me. And it was very shocking. So you have like these amazing presentations, super inspirational. And then you also get super humbled in the same day, because your first day of class or your first like competitive event at Stanford, where it's like intellectual competition, you just realize that everyone is just a genius and works incredibly hard and gets things faster than you. So that was an interesting kind of juxtaposition.
I mean, Stanford plays a pretty pivotal role in the evolution of your company now. So tell us how that solidified, how that came to be.
So we built Nitricity from our backyards, or from like Airbnbs in Fresno. So Josh McEnany and I started working together at Stanford. And he had this great house in East Palo Alto with a backyard. And like we got some tools and a workshop going there. And we put up a CAD computer for mechanical design inside. And then we had Jay Schwalbe, another co-founder, move in with Josh. And we were doing very advanced lab work in Stanford labs on, combustion sciences or electrochemistry. And then after doing our lab work, we would drive to East Palo Alto to Josh's backyard and try to hack together our new product connected to a solar panel, making fertilizer with like an Allen wrench and duct tape. And that was a real journey. And so that's kind of where it all began. But we were building this piece of technology that you put down a solar panel and you put some equipment underneath it, and it converts solar electricity into fertilizer. So you had to add a little bit of water, and then it pulled air through the system and turned sunshine, air, and water into fertilizer. And then Josh had this great lemon tree in his backyard. And so, we would pour out the fertilizer samples on this lemon tree, and this lemon tree is now, 200 feet tall. Beautiful, of course.
So where did the idea come from originally? Like, what planted the seed?
Well, I'd love to tell you it was like we woke up one morning and we got it. But it was actually the result of like assiduous study and pursuit over years. We started at the problem and worked towards a solution. So the problem statement was as follows. Today, 5 to 7% of total global greenhouse gas emissions come from nitrogen fertilizer. 1.6 to 2% of total global emissions comes from the production process, which burns fossil fuels. But then about 5% of total global GHGs come from nitrous oxide. So it comes from when you apply fertilizer to fields. you get a gas that comes off called nitrous oxide, which is 265 times more potent than CO2. We started looking at the production's emissions challenge. Let's produce fertilizer with air, water, and electricity rather than natural gas. But we were also very focused on the application emissions and became increasingly more so focused on the application emissions over time as we started working with farmers and on farms. So we knew we wanted to make a technology that produced fertilizer with electricity because of the huge climate implications it could have, and also the huge like food security implications it could have. Fertilizer security is food security in a lot of the world. And we looked at 30 different technologies that could do that, and did a lot of travel to labs, did a lot of reading. I remember reading, books and books and books on fertilizer, and a lot of discussions, a lot of Excel sheets projecting the cost of this. I even remember, we found one technology we thought was promising at one point, and I drove up to someone's house in Oakland who had a textbook in his basement, and we tried to pull some numbers out of that to see if it would be economical. And so it was really, a well-defined problem statement and then a hustle to try to find a solution. And we centered on this one after trying about 50 other ways it didn't work.
You've got a great line that defines the process as harnessing the power of lightning to make fertilizer. Can you explain kind of in layman's terms for folks like what the process actually is and how it's different?
This is where I get to lean into you and I's Colorado roots. Right. So Colorado has these like really aggressive thunderstorms sometimes, especially where I'm from. And then after a thunderstorm, if it's sunny the next day, it's a real treat because in the morning it's extremely green, or like the flowers will be more brilliant. And that's, partly because of the water, but also partly because of fertilizer. So when a bolt of lightning strikes, it creates a plasma, very high temperature, a lot of energy. And plasma will break down nitrogen that's in the air. Nitrogen is present in the air all around us. It makes up 78% approximately of the atmosphere. But it's in a triple bonded molecule. So nitrogen in the atmosphere is extremely stable. It wants to stay as this inert nitrogen gas. It's actually the second strongest chemical bond in the universe. But the force of lightning and those extreme temperatures and that plasma will sever the triple bond of nitrogen that's in air. And then rainwater will react with that broken down nitrogen and oxygen in the air and bring it down to the soil as fertilizer. So this has been a natural process. That's part of the nitrogen cycle. So a huge amount of nitrogen every year worldwide goes from the sky into the soil with a totally natural process of a thunderstorm. So lightning and rainwater. And we got to see that firsthand growing up in Colorado.
Yeah.
And that's the same approach we use to make fertilizer. After many different iterations, we have a reactor that has a suspended bolt of lightning in it. And instead of powering that lightning to form based on like atmospheric discharge, we power that lightning bolt with energy from renewable sources. Yep. So either solar or wind or hydro. And then therefore we can make a natural fertilizer using nothing but air, water, and electricity. And so that's the idea. The crux is this lightning in a bottle reactor. It's very tough engineering to keep lightning in a bottle.
And an apt metaphor for the real product, right?
It is, yeah. It's magic. It's really cool. You walk in the shop today and you add water to the system. You turn on like 10 different switches because there's different subsystems. And then that water will be fertilizer by lunch. We run it longer than that to make it, stronger, but it'll be usable by lunch. And you can make a lot of fertilizer that makes a lot of crops with a pretty small system.
And just to kind of summarize for folks, it's fertilizer that's created without the input of fossil fuels, with energy sources from renewable energy. And then I guess the second part of that then is, you've got this product critical for agriculture, critical for food security. You've got a cleaner version of it. So what does that look like? How does that then manifest for the farmers in the real world who would use it? Talk to us about what it looks like on the ground.
Yes. So today farmers receive these plastic caged IBC totes that have fertilizer in it. And that's the exact same thing that can happen with this technology. But today that fertilizer, that California makes zero of its own fixed nitrogen. So today, we're in California. Nitricity is in California. California farmers import 100% close to 100% of the nitrogen from out of the country or out of the state. And so nitrogen comes in ports, and then sometimes a form of nitrogen is converted, but that nitrogen fixation process happens from a factory that's thousands of miles away. And there's this huge supply chain. And then at the end of the day, the farmer gets a plastic tank with fertilizer in it. And in California, they send it out with irrigation. California uses a lot of like irrigation systems. And what Nitricity does is we offer the same final product. We give you fertilizer in a tank. It goes out with the irrigation kit, but that fertilizer is made in the local community using a renewable process. So the supply chain is very different, but the final end user gets the same experience.
And I mean, what was it like testing, seeking, investigating, and working in the field, literally, as you kind of evolved this idea into eventually what becomes a product and a company? Like, I have to imagine there's some great stories from testing the subsystems in the real world on farmland or around California in Fresno. You mentioned earlier. Like, talk to us about some of the stories of the building process.
Sure thing. The first real project we got, I gave a presentation with one other member of our team in Fresno about what we're building, and we built this small prototype. And a farmer stood up in the back of the room and he says, "I'll give you like $10,000 if you build one on my farm." And, we had to take it. I mean, that was huge.
Product market fit day one.
Oh my gosh, it was wonderful. I mean, I gave that same presentation 100 times in Silicon Valley and everyone said like, "What's fertilizer?" And then I gave that pitch down in Fresno and people were like jumping out of their seats. They got it immediately. And so we got this project to build a solar on-farm fertilizer system in Fresno. And we built the whole system, installed the solar array there. It was about the size of a pickup truck. And then we built our technology to fit in two 55-gallon drums. And we built that technology in Josh's backyard in Palo Alto. And we tested it. And there was, you have to, it's the engineering cycle. You test it, there's a problem, you fix it, you optimize it. Some of the problems are really weird, but then we got it working and we were super excited. And then we put it in the back of a rented pickup truck and we drove it down. And we said, the plan was, get there at 9, install between 9 and 11 and go for an early lunch. And I just watched because it posted data to the cloud. So we're just going to watch it work. And it was pretty clear by 11 that this was going to be a lot harder. We got there and a component broke down and blah, blah, blah. It was working, but then you need to make a minor modification. And then long story short, we ended up renting an Airbnb for 3 months and going to the farm every single day to optimize and rebuild the system in place over the course of months. And we started the project and it was rainy and cold. And then as we worked on this farm, day after day, like several co-founders cramped into an Airbnb. I was sleeping on the floor. Someone was sleeping in the closet, and we just wake up early, have a cup of coffee, drive to the field, work, take a lunch break, come home at the end of the day with samples of how much fertilizer we made. And then we had this UV vis spectrometer on the Airbnb table. And we test how much fertilizer we made at the end of every day. And that means we had to eat on the floor because our spectrometer was on the Airbnb table. And it started cold. And then, as we approached growing season, it got really hot. And I just have such an appreciation for people who work in agriculture and on these farms because it gets super hot and dusty and it is hard work.
Yeah.
The tomato transplants went in and, it was a race against the clock. We had to make enough fertilizer to compete with the control. And, time was ticking. It was a 120-day growing season and we needed our system to run. And so we were out there and, there's even some days it was like 115 degrees. And the folks who work these farms are tough because it is really grueling conditions and it is dusty and there is black widows and rodents. And it was a tough environment to build this system, but we got it done. And then also the big thing is the whole community rallied around us. They were so supportive because they saw these crazy kids out there working all day long on this weird technology that would emit all this light. When it was working, it would pulse because every time a lightning bolt would go.
Sure.
You could see this thing probably from outer space because we had a glass reactor at the time. So the community really rallied behind us. I'll share one story in particular. As our whole system went down and we didn't know what to do and we couldn't find a replacement part and there's a race against the clock and someone had an idea saying like, hey, a microwave oven has like this specific type of like resistor No, it was a toaster. A toaster has this specific type of resistor, and let's just go buy one at Target instead of waiting for this like legitimate resistor to come in. So, to get the project on track and on timeline, we go to Target and buy a toaster. And we're planning to like destroy the toaster and take out a resistor. And the lady was like, "Do you want a warranty on this toaster?" And I said, "No, ma'am, we're going to destroy it." And then we go smash the toaster, take out a resistor, put it into our system. Everything is working just fine. And, we worked for another month.
It sounds like within that period, there were some days where you didn't have the confidence that you're going to beat the control. How did you kind of push through those moments of uncertainty?
Oh, I think just madness.
It takes that to be an entrepreneur. It takes a little bit of that.
At this point, we were just delusional and crazy. Yeah. I mean, the most important thing is you just have a really good group that's excited about something, and you have a lot of people rooting for you, and you don't want to let them down, and you're having kind of a good time, even though it's a lot of suffering too, because you're together. So if you're working with a good team that's like really excited about solving a big problem and you have some support, it was no question.
Yeah.
And, there was one day where we just like had to take a break. We were exhausted and it was hot.
Yeah. That's part of it too. As you get this product up and running and see the results and compare them to the control, was there a moment where the opposite happened, where you thought, okay, we've got something that's not just real on paper, but that's real?
Yeah, at some point we got it working and it just needed no more maintenance, and it would just run continuously for a while. And we drove back to the Bay Area, and then we did some preliminary tests and we got a couple grants and we did some analysis on the cost economics, and they looked quite compelling. And then not only that, but we started building another project on another farm. And I got a call from the farmer and he said, like, "What are you doing today?" Like United States Secretary of Agriculture, Tom Vilsack, wants to see a project and he's going to be on the farm on Thursday morning. And that was like you have all these investors and politicians that are like shocked at what you've built. And it's a couple of dusty guys on this farm with wrenches. So that was pretty eye-opening. It was pretty surreal.
How did you get, I guess, from working in the fields to taking a product and shopping it around with your friends on Sand Hill Road? And, how did investors receive this? How did you pitch it? Walk us through that transition, because it's a very different day-to-day.
It is, yes. There were some points I was just very stressed about, making sure we had enough money to keep operating. We had members of our team rolling out of school. Everyone was concluding their PhD or postdocs, and they wanted to work on this because it was exciting and everyone thinks it can change the world. And they saw that. And then they see this like group, everyone, we're building this, we're having a lot of fun. And so, I said, let's like get you a salary. And as soon as you commit to like paying people, I mean, sometimes you just have to take this leap, but then you're on the line to make payroll. And that was a pretty heavy burden, because there was a period where it was like, that's the only way this initiative succeeds, that people are working on this, but that needs money sometimes. And in the early days, we were very lean and it was really tough. I mean, we're talking week by week, month by month, making sure you got enough money in the account. And so, we would put our prototype, I'd organize pitches with different folks, and we put this prototype in the back of my Subaru and bring a solar fertilizer system into an investment bank and pitch it and turn it on and all this stuff. And some people just didn't get it and other people's did. But then the big thing is, after 200 pitches, you start to learn, you start to make progress as a company, and you also start to learn like how to communicate the market opportunity and like what questions are going to be asked. And then also like really, if you need the money, you're going to put a lot of pressure on yourself to like make sure you're prepared and you do the best job you possibly can. And that's just required. And don't take it personally when you get 200 no's.
What were the questions that you got that you refined answers to until you had them perfect? What was kind of the most common question from investors, in particular investors that, you wanted in the space, the ones that you would have wanted in the deal? Were there any kind of common questions that kept coming up?
A lot of questions on the business model and the market opportunity and the market segments, and a lot of questions on how we're going to grow the company and how we're going to get revenue and what our projects are going to look like exactly, and what the cost structure looks like for that project. And yeah, it took some time to learn like the right vernacular and like how to communicate risks. Like, hey, here are the 3 investment risks that you have that I think are big and worth paying attention to. And here's how we're addressing each one.
Yeah.
In a way that inspires confidence, but is also very transparent. So it's just like building a new muscle or skill set.
How does it compare to the world of engineering? Like, what are the crossover skills or aptitudes that came directly from engineering versus what was brand spanking new?
It's a good question. A lot of it felt new. I mean, but technical communication was critical. The technical communication parts of my training, like the PhD, the writing and presentation skills I developed proved more critical than I thought they were going to be at the time of learning them. So it's like that engineering writing class that you're taking in undergrad to get the credit. Like that's actually extremely important and things like that. And then also, of course, like a fundamental understanding of economics and comfort in being able to learn a new skill by looking at the reference materials.
Were there any, you came onto my radar because of some investors that saw that I think posted about you. So I'm curious if you had any investors who really, when they showed up, you felt validated, you knew you were in the right game with the right teammates in terms of who was providing financial support.
Well, I have to give a big shout out to the folks who have made the journey down to our farm projects. You know, the exciting thing that we've done with every fundraising round is we've built a syndicate that is only for farmers. And so within each like funding round, Series Seed, Series A, we make sure to pitch the deal to farming investment groups. Mm-hmm. And there's a lot of due diligence there. And these folks will want to like step on the field and take a look at it and drive up. And that is like actually some of the hardest deals to close.
Sure.
Because the questions are tough and they're going to look at every aspect of it. Another big one was Energy Impact Partners has supported us since we're very early. Lower Carbon Capital, since we're very early. Lower Carbon was the first to believe in us and really helped us on our first and our hardest fundraising round. And then Energy Impact Partners came in and later and they visited the farm when it was 114 degrees that day and looked at the technology and studied it in depth. And that means a lot. Every single one of our investors are super right now, and their support has been invaluable. And I have so many great stories from talking with them on like FaceTime from the field, showing them what we're building and them being curious and asking the hard questions. Coastal Ventures has played a huge role, as well as Fine Structure Ventures. That group is incredible as well. I could talk at length about everyone who's supported us and go on. But yeah, you can't do it without these folks. And they ask tough questions and you want to make sure the company succeeds. And then on the team side, as we've grown the team, you know, this is hard work. There's a lot of jobs in Silicon Valley that are way easier than this. I mean, like building a revolutionary new technology and then installing it on a farm, or doing something like fertilizer, which is such heavy tech involving like chemicals and plasmas and things like that, takes a lot of grit. And so investors make the opportunity possible, but then the team is really who delivers. And it's just amazing what happens when you get a good team together. And the amount that they put in is just spectacular.
Yeah. I want to get back to this idea of the syndicates from the field themselves. I know the field trials and pilots you've done have developed into a bunch of great partnerships in terms of the farm and ag community. I remember hearing a story that you actually had to kind of rejigger your website because at one point there was a little too much attention, too much traffic coming your way. So I'm curious clearly there's a product market fit on the customer demand side. Talk to us about understanding that, making the most of that, leveraging that for growth.
Yes, we got a lot of news and opportunity when we had like 7 people on the team and closed our early investment round. And at that time, you don't know what to do with all that with as the next step. It's kind of shocking, right? You have all this investment coming in. You have we had 7 projects and 7 people. And so, we had to just develop a form response and call everyone and say, hey, we are extremely grateful for this opportunity. We need to staff up our organization first and get an office and work through how we can best serve you. It's going to take us a little bit of time, but this is very much an opportunity that we want to work to realize. And that is not saying no, but it's saying hey, give us some time to where we can be in a better place to serve you. It was also something important to develop because if you just take on too many commitments at once, you'll feel like you're going to explode. And so balancing the market interest with your capacity But then being ambitious and growing your capacity was something that we had to do.
As you think about kind of the growth and the potential impact that your technology can have, as you envision it kind of at scale, talk to us about what kind of sustainability impact we're looking at here.
So fertilizer accounts for 5 to 7% of total global greenhouse gas emissions. And the easy bit should be we need to electrify how we produce it. So that's 2% of total. And that just needs to happen. And a huge retooling of the industry must occur to do that. And companies of enormous scale are going to be developed to help realize that. So that's thing number one. Thing number two, which is a greater impact opportunity, but is more subtle and more challenging, is the type of fertilizer you apply in a soil affects the amount of nitrous oxide emissions that come off. And it just so happens that the type of fertilizer provided to soils from lightning-based nitrogen fixation is, in most soils, ultra low emitting of nitrous oxide. So in all soils except for flooded soils, lightning-based nitrogen fixation and the products that come from that emit very little nitrous oxide emissions and much less nitrous oxide emissions than conventional fertilizers on the market today. And so there's like a communication challenge that needs to occur in persuading the industry to shift towards these lower emitting fertilizers. And these lower emitting fertilizers are more expensive to ship. That's the hard thing. The fertilizer that comes out of our process has a lower nitrogen percentage by mass than what comes out of standard factories today. And so it's a little bit more expensive to ship, but it emits a lot less when you apply it to fields. And so the supply chain has to also change as well. Sure. But I think looking down the road, there's an opportunity to take the 5 to 7% of total global greenhouse gases from fertilizer and bring it close to 1%. There will always be some emissions that come off the field as nitrous oxide. It's part of the nitrogen cycle, but it can be reduced by a huge amount fairly quickly too. We just need to change what type of fertilizer we're applying per soil.
And you talk about these in terms of market opportunities. I mean, I think we talk with guests a lot about the idea of a purpose native company where the positive impact that you're having is directly tied to your own financial success. Like these are opportunities, market opportunities, financial opportunities, profit opportunities. I'm curious if that was something you were cognizant of, as you started planning. Did you aim to have something that was purpose native from day one? Or did you realize the opportunity as you kind of started looking at solutions to the problem and realize, okay, here's something that has product market fit, meets a market need, will deliver profitability at scale, and delivers impact at scale?
The problem statement centered around the greenhouse gas emissions reduction.
Sure.
And the food security thing. So our mission statement is tied to reducing emissions in the industry and promoting food security by electrifying and distributing production. And then the constraint is the economics, is you have to find a way to make that work within the market. And so that's how we thought about it, is mission and vision were focused around the impact, and then the constraints that you solve for are defined by the economics.
Yeah. We've had a ton of great conversations with folks in the agriculture space, many of them working in various streams of regenerative ag. I'm just kind of curious to hear your take, taking a step back at the entire landscape of agriculture and food security and agriculture demand. I think I am one of the people that thinks that all of these solutions are part of a path towards a better food system in all ways. And we don't, it's not going to be one as the ultimate winner, but a combination of all of these are part of the solution. But I'm curious how you see it.
For me, I see a change in the industry happening right now on the energy side, because that's just my focus area. There's this revolution coming from solar and wind, offering all these opportunities to build different devices to support productivity in farming. And then on the consumer side, I see it as people care what they eat. And you see this with so many different labels that are on foods, is the consumers and people around the world really care what they eat. And it's an integral part of every single day, multiple parts of people's days around the world. And, the baseline is making sure everyone has enough nutritious food to eat. But then as that baseline is met, there's just layers and layers upon that is okay, now that I'm not starving, I want to make sure that there's no pesticides that are going to cause negative health effects in 20, 30 years for me and my family. And so people don't realize how much food plays into our lives, and people care about what goes into the food that they eat. And from the energy side too, it's not just about making these different chemicals. It's about ultimately serving people who are eating this food and trying to make food in the right way and where it is needed. So
Yeah.
I think there's an opportunity right now to like shift the focus of the industry away from this, like the soil as a factory, and more towards designing the energy ecosystem to support getting products to the field that then make high quality, accessible food for end consumers.
As you kind of, I mean, still living in the heart of American innovation, and I'm sure with a bunch of peers and friends who are, alumni of Stanford's various esteemed energy programs or graduate programs, I'm curious, what are the trends you're seeing, the big innovations out there, whether it's in climate tech, in sustainability? What big breakthroughs are you looking at going, okay, this is, there's some other cool stuff happening. What's exciting to you right now?
I really like watching the steel industry and the cement industry. There's some big innovations happening there to electrify that. And personally, I find that really exciting. It needs so much energy too, and it's a very hard engineering problem. So that one's huge. And then the other innovations that looking at on the ag tech side, I find pretty interesting, like innovations to do different weeding approaches, or some of the steps that I saw being on the farm.
Yeah.
That are a lot of people are working on that are extremely tough right now, and without the use of just a blanket chemical. So that's kind of the two classes that I'm watching.
We've had a couple really fun conversations in the industrial decarbonization space with cement and concrete innovators. And it's really inspiring to hear folks that are like doing cool stuff and solving hard problems and building really high potential, high growth companies. It's really inspiring. What's been interesting is some of the places where these intersect, right? So we talked with Rick Fox, the guys that started Partana, which is a concrete company, and they've actually been partnering with the steel industry to try to repurpose the steel byproducts as part of their cement processes in creating the next generation concrete, which is, it's just, again, like people coming at these problems from such unique angles and finding creative intersections that kind of give me renewed hope that some cool innovations are out there. Although if you've got good steel folks we should talk to, let me know.
That's great. Yeah, the heavy industries are just, they're in the background of society, but it's so much work to electrify those. It's unbelievable the amount of man hours and people hours going in.
Yeah. I mean, along these lines, I tend to ask everybody, you're hearing headlines every day. This week in particular, we're recording this in mid-December. So we're hearing the headlines coming out of COP that I think can be depressing for some people who are diehard environmentalists, and not every headline is optimistic. And so I'm curious, how do you stay positive and work towards developing solutions and innovating when I think sometimes certainly the news environment can make us feel like we're so far behind schedule that there's no hope. How do you, my phrase for it is defeat defeatism?
For me personally, just try to stay focused. There's so much opportunity with what we're building. Wake up, have a cup of office, have a cup of office.
Yeah, that's
have a cup of coffee.
Sounds like an entrepreneur right
come
there.
To the office. Yeah, just have a cup of coffee, come to the office, and do the best I can with the time that I personally have, and spread awareness on the things that you think are low hanging fruit. I'm like this nitrous oxide fertilizer emissions thing.
Yeah.
Because a lot of change can happen in a lot of areas just from talking about it. So like there's, retooling the whole fertilizer industry and how we produce it. That only affects like 2% of global emissions. Whereas if we just talk about it and switch the types of fertilizer we're using, you could decrease 5% of global emissions. And so, it's worth talking about it. And then for me personally, I just come to work and have a cup of the office every day.
It's going to become a new catchphrase, the cup of the office. Where can folks that want to learn more find out more? Where can we send folks to get educated on the products and what you're doing and what you're excited about?
Well, of course, our website, we have a really exciting announcement coming out. So check it out. And then separately in our space specifically, I want to give a huge shout out to the International Fertilizer Development Center, founded by Henry Kissinger several decades ago. There's this fertilizer development center in Alabama that has invented how the world uses fertilizer today. It invented the ammonia bar. It invented diammonium phosphate, briquettes of urea and deep placement of that. It's a nonprofit that's fundamentally changed the world and probably saved like 1 billion people from starvation across all their efforts. They wrote the book on this industry, and the folks that work there and who are working on it as part of our partnership, I think that's a great place to look for like innovations in our sector.
Awesome. we'll put them into the show notes, along with, of course, all the links to your company and all your updates and news releases as they come out.
Super.
Yeah. Thank you so much for taking the time. It's been really fun. I think this is you said the word low-hanging fruit. I think there's a lot of conversations to be had on some of the promising innovations that actually bring, a wealth of opportunity and relatively high scale and relatively easy to achieve if we just focus in on it a little bit. So thanks for being a part of the solution, and thanks for having the conversation with us.
Yeah. Thanks for having me. We'll have to go to Woody's sometime together if you're ever in Colorado.
Exactly. Awesome. Huge thanks once again to Nico Pinkowski for joining us on today's show. I think understanding the challenges at the root of our food system is hugely important for all of us as we strive to build a more sustainable future. And I know for myself, I feel like I've learned a ton from talking to Nico about the role of fertilizer production and the opportunity for decarbonization there. I'm super excited for the technology, and I'm hoping to get to see that lightning in action soon. Stay tuned. If you want to learn more about Nitricity, keep up with their latest announcements, or look at the products for yourself, you can visit the website at nitricity.co. We'll also have a link for you in the show notes. And for those of you who want to do a deep dive into the topic of fertilizer in general, we'll also provide a link to the International Fertilizer Development Center that Nico mentioned. They have a wealth of information on the latest projects and initiatives across the globe working to increase food production while decreasing environmental impact. You can also follow Nico himself on LinkedIn at Nicolas Pinkowski. That's at NicolasPinkowski. For any questions, comments, or ideas sparked by today's conversation, or if you have a great idea for future conversations, email us at cic@consensus-digital.com. That's cic@consensus-digital.com. Drop us a line with your reactions to today's conversation. We'd love to know what you're thinking. You can also connect with me directly on LinkedIn and Threads at CKGONE. And as always, if you like the show, please give us a follow, a like, or leave a review wherever you listen. It really helps us grow our reach and continue bringing you more awesome conversations with the business leaders you want to hear from. Thanks, everyone. We'll see you next week with a brand new conversation. Consensus in Conversation is hosted and executive produced by me, Conor Gaughan. The episode was produced by Will Gatchell and Jeff Rock with editing from the good folks at Reasonable Volume. Special thanks to the Consensus team, including creative director Kate Tucker, Greg Hergel on research, and Patrick Gallagher on strategy. Consensus in Conversation can be found on Apple Podcasts, Spotify, YouTube, or wherever you listen. Consensus in Conversation is a podcast by Consensus Digital Media, produced in association with Reasonable Volume.